Good afternoon, ladies and gentlemen of Bachelor of Honors. We're going to be working on some word problems today. And so basically it's applications of exponential decay problems. So we got a quantity of insulin used to regulate sugar in the bloodstream, breaks down about 5% each minute after the injection. Body weight adjusted dose is generally 10 units. How long does it take for remaining insulin to be half of the original injection? What do you think? I want you to kind of look over here because you see under financial math, I put that those formulas, we're going to be using those in financial math. Right. But they really have application here, especially that one that's a simple interest. You see that? So I'm going to write that down here. So that equation is A of t is equal to P, and this little zero here is P sub 0, and it's going to be 1 plus R to the power of t. Does that look familiar at all to you? Should, right? 1 plus R to the power of t, does that look familiar? Okay. So basically, we're going to use this equation to kind of figure things out. What goes in for what here? So R equals 0.05. Where'd you get 0.05? How do you, from here, right? How do you quantify going down? How do you mathematize that? Negative. Yeah, so we're going to go ahead and do this, right? Right? Mm-hmm. So now do we have enough to fill this out? Yep. Let's do it. So we have A of t equals ten, right? Body weight adjusted dose, 10. And we have 1 minus 0.05 to the power of t. And then it says t is what? T equals what?
5 minutes.
Minutes, right? And you'll see this in this situation is days or years, depending on what the application is. But you just kind of look here, each 5% each minute. Okay, that's the giveaway, that minutes is what T is standing for. And then, how long does it take for the remaining insulin to be 1/2 of the original injection? How do we figure that out?
Over 2, 1/2 equals.
What did you do, half of 10?
Half of 10, which is 5. So let's go ahead and do that. So we have 5 is equal to 10. And then I'm going to go ahead and truncate this one. I'm going to call it 0.95 to the power of t. Now how would you work it out from here? What did you say?
Multiply 10 and 0.95 again.
No.
I would divide by 10.
Yeah.
No, let's talk about why we can't do that. Now, what happens is, you could do that if you had this to the same power as this, but this is the power of 1, this is the power of t. So these are things you can't multiply together. You can't distribute that 10 in there because of that. All right? So what did we, so I was distracted by that. What did somebody else say?
I said divide by 10.
Divide by 10, okay, let's do that. So we divide by 10, so we're gonna get, we divide by 10, we get 1/2 is equal to 0.95 to the power of t. What next? Okay, well, what I was thinking somebody would do is take this thing right here and write out a system of equations to solve for your calculator, which would be like y1 equals 10 times 0.95 to the power of x. Y2 equals 5. And go to your calculator. Let's do that. Y equals, we'll have this one equal 5, this one equal 10 times 0.95 to the power of x. Okay, as far as the window goes, usually for these things we only need to worry about quadrant 1, so we can reduce that. And I think the thing starts at 10, so I'm just going to leave the max at 10 here, and I think we're going to be good on this. Maybe, maybe not. Let's see. Not quite. We don't have quite enough window to work with, do we? So let's make that maybe 20. Maybe that'll work. If it doesn't work, yeah, it looks like that'll work. So now the question is, how many minutes? How do we find the minutes? Second trace 5, enter, enter, enter. The second trace 5, enter, enter, enter. So about, what is that? 13.513. So we say T is equal to 13.513. So we would say about 13.5 minutes. Is anybody here thinking of going into nursing as a profession or a medical profession somehow? You are? Okay. What this is this type of, you got to worry, you got to worry about stuff like this, don't you? Insulin and blood sugar and different dosages of things. Okay. This is not that hard, is it? Now, we're going to learn about solving logarithmic equations here pretty shortly, and for that we're going to be able to use algebraic method to go ahead and solve for t, but that's going to be maybe starting next week. Questions on that? Now really, if you look at problems 15 and 16, they're really pretty similar to 14, so I want you to go ahead and look at problem 15. And I think 16 is similar too. Yeah, so 15 and 16. So what I want to do is look on 15. I'll call on somebody here in 3 minutes. Thank you, thank you. Good job. I don't hear you talking to each other very much.
I'm lost.
Oh, I got the answer
We're
already.
just off.
Is 1.5,
Oh, so you're
0.886.
Is
talking-
negative, is negative 11.4 the rate?
It just says it decays at a rate of 11.
Yeah, when you say you're lost, I want you to be talking to each other about that. Try to get unlost by talking to each other.
The answer is 60.
Look at problem 14. 14 is like a typecast for this one.
This is way more words.
It says.
I think the 1.5 doesn't really.
Well, yeah, but then that's
It's
only
actually
objective.
11.4% is coming from.
Yeah, I think that would be
Think
kind
that's-
of important.
Yeah.
Yeah, probably.
Yeah.
Okay,
Those,
Yeah, so this one, they took more effort to kind of dress up the numbers, didn't
Oh,
they?
yeah.
too much effort, you ask me.
But it still ends up being the same thing, isn't it, as problem 14, if you just think about it.
I guess the 1.5.
So basically, you're going to be writing an equation and then using that function or equation to find that last thing.
Simplicity.
Okay. Let's go ahead and get someone. It was Haley. Haley's not here.
A.
Of course.
Yeah, that's the way it works.
Lucky dog.
So this time it's going to be Chloe.
I don't know what.
I know the
I don't
equation.
know what P0 is.
I didn't hear the.
Don't you know what it is?
I know the equation.
Don't know what P0 is.
Don't you know, Chloe?
I know, I should.
Do you know what everything else is?
Pretty much.
Okay, let me show you. Does anybody know what P sub 0 is here?
No.
0.2,
I don't know. It's the 1.8.
0.886.
1.5.
Yeah, P sub 0. P sub 0 equals 1.5 parts per trillion. I'll call it PPT. Parts per trillion.
Alright.
So now you have it, right? Okay. So what is our equation for this?
Point 2 equals 1.5 times 1 minus 1.14 to the power.
So 0.2 equals 1.5 times
1 minus
1 minus
0.114
114
to the power of
power of t, yeah. Okay, so what it is this is like, she's really setting up to determine at this point. Let's go ahead and dial back to get the answer. Let's see, it's called concentration. We'll call it C of t is going to be equal to 1.5, and then it's going to be 0.886 4.86, is it?
No.
Not that that's hugely important. To the power of t, and t equals,
60.646818.
Huh?
t is millennium, right? So t is equal to 1,000 years, right? Which is a, okay, Chloe, what'd you do next?
I plugged it all into my calculator.
So you put this one in like, let me just see if I can read your mind. So we get like 1.5 times 0.886 to the power of x. Is that right?
Yeah.
And y2 equals 0.2.
Yep.
Let's go do that in the calculator here. So we have 2.5, or 1.5, excuse me, times 0.886 to the power of x, and this is going to be 0.2. And then I know that the window is not going to be exactly right. Well, pretty close. I'm going to go ahead and just make it a little more visible. I'm going to go to here.
21?
I'm going to go to, yeah, sorry, I'm going to go to 30. Why not? So second trace 5. Enter, enter, enter. So that's what you got there? So 16.647 millennia. Millennia. So that's going to be how many years about? Or 16,647 years.
Wait, so what is that a picture of? A person pointing at
Yeah, I don't know what that picture is.
He has a fork.
Looks like it's a hand of something
It's a human hand.
measuring things like our tweet or something. So
No, that's.
anyway, I want to tell you.
Glass.
Magnifying glass. Okay, let me tell you something that is that we're going to look at in pre-calculus next year. Is a similar thing. It's called a half-life equation. The half-life is you're going to have. It's going to be a of t equals your p sub 0, and you're going to have 1/2 to the power of t over your half-life. And for carbon-14, what you have is your half-life is 5,730 years, I think. So what you're going to have is 0.2 equals 1.5 times 1/2 to the power of t over 5730. I'm just going to try to see how well this matches the answer they have here. I'm just call it a fit of curiosity. So I'm going to have times, let me clear this out. So 1.5 times 0.5 to the power of, I'm going to put x over 5730, and I'm going to leave everything else the same here. See what happens. I'm just curious. Oh, okay, I know what it is. It's not millennia, it's thousands of years, so I got to change my window. So I got to make it, if it's going to work, it's going to be, I'll give it 20,000 years. How's that? We'll go by thousands. See if this works. Okay, second, trace 5, enter, enter, enter. Oh, what do you know? 16,656. So just a few years off, about 9 years off. So anyway, that's what it is. Yeah, thank you, Chloe, good job. And the thing that was really good is she had everything figured out except for that one thing. And we were able to straighten her out on that pretty well. Thank you. I want you to go ahead and look at number 16. We will recruit somebody again for that. By the way, half-life carbon-14 dating is accurate to about 50,000 years. And that's why it's really helpful for human history, because human history is within that time frame. It's not as helpful for long-time geologic history. Music, stringed instruments. I guess we could do an experiment with the guitar strings over there. I hear people talking to each other. Is this just a quiet class? Are things really relaxed today? Is that what's happening?
It's been a long day.
It's because we have a class view.
Allie, did you get your calculator charged? You did?
A little bit.
A little bit. Yeah. Here. Let's see if I can find my adapter again. Well, a whole lot of class time left. No. Atlee, you have one of these cables at home for your calculator? You do? You get a little bit of charge out of it.
Yeah, I don't know if my calculator is better than for him. There's no reason.
See here. Let's try it out. Again.
I was just through bed.
Looks like
Have one nap. I'm pretty sure I'm marked.
Yeah.
When I tell you
When
that I went
place like that.
she brought it all the way to my room.
All right, let's get somebody here for this one.
But when I tell you, my mom was mad.
Okay, let's go here. We got. Okay, it's going to be Haley again.
It's okay.
Haley, it's the second time we've called your name today. So I guess it was just determined, the wheel was just determined to have you participate, Haley. What do you got on this one?
No, R is 0.25.
So R equals 0.25, okay?
It's 0.1
So 0.1,
equals 0.75.
0.75,
And then parentheses, 1 minus 0.25 divided
of T.
and then here. Write that again, 0.1
0.1,
equals 0.75. Parentheses, 0.75
5,
divided
T.
and then you put it in the calculator.
Okay.
My 1 is 0.11.
So 0.75 times 0.75. Did that confuse you to have both those numbers be 0.75? It would me a little bit, maybe. So like that?
Yeah.
And then probably for your window, 0.75, that's not very, so that'll work out, you can keep that.
20,000.
The first one's a little.
20,000, we can go back to 20 maybe, right? So something like this, yeah, that'll work, right?
Yeah.
Second trade 5.
Second trace 5.
I like it.
So that, right? So 7.0039.
7 seconds.
Good job, Hank.
So that's going to be, calculate the time, so about 7 seconds.
Yes, sir.
T equals about 7 seconds. It says find the, calculate the time. Yeah, so that's it. You got the thing. So that's going to be it, isn't it? Okay? Questions on this one?
I need help over here. My calculator, I have it in the equation, but I don't have it. It's not graphing it like that.
Not graphing like that.
Mine didn't do it.
Why don't you go ahead and look at your next, the next problem 17. Let me see if I can get at it. On track.
That's what I put in there.
Oh, it's one better, but
Probably it's a matter of so X min, here it is, right? X
You think Siggy's still talking? Makes it work.
yeah.
You think Siggy's still talking? Probably.
Yes.
You don't need negative
You go zero.
here. So you should see it here. It should be very thin, very low. Let's see if the windows can see it better. Just go to Y max. See, it starts at 0.75. So you take Y max down to 1.
And you didn't eat them? Rude. I know now, I'm going to see what else
So, playing around with the windows, just get used to the calculator, more experience with that. It'll be fun. Yeah, playing around with the windows, that's part of what becoming adept at calculator usage is. Just, there's not a whole lot of, it's not hard, just it's experience, that's all it is.
How do you reset?
How do you reset your calculator?
Yeah, I can.
Zoom 6. Zoom 6 will set your calculator back to the standard settings. And so that's, sometimes if you mess up your whole window, I don't know where I am, if you go to Zoom 6, it just takes you back to home base. And then you can adjust from there if you need to. So analyze relationships. Compare the graphs of fx equals 1/2 the power of x and x to the 1/2 power. Which of the following properties are the same, which are different? We can just quick go over these here. In fact, what I'll do is I'll call on somebody to give me the answers for this. You're ready to give me answers. Let's see who's going to give me answers. Or be what we call primarily responsible for that. Oh, it's going to be Randy. All right, Randy, what do you think?
I got for domain x such that x is equivalent of all the numbers.
So, for which one?
Domain.
Domain.
For both of them?
Domain. Just domain.
But for which one? You got f of x? For which one?
Both of them.
You're supposed to choose A, B, C, or D.
Why?
What? No.
You're not.
Yes, you are.
Which of the following properties are the same? So out of
Yes.
all of those, which ones are the same? for each
Yeah.
group?
Oh.
So which properties are the same?
Oh, A and B.
A and B.
I'm second. I don't know.
I'll put question mark here.
Yes, sir. Wait, what?
Okay, look.
It can only be one of them. It's
Look.
B.
Okay, look.
Look,
Here are the graphs, okay? Here's f of x, right here. F of x is like this. Here's f of x, right? What is g of x?
Like this.
G of x is, so here's g of x, and here is f of x. Are these domains the same?
no.
No, they're not.
So it's B.
So which one is range? Is the range the same?
Yes.
No, it's not.
Oh.
End behavior,
It's,
end behavior as x increases, is that the same?
Yes.
No,
No,
it's
it's
not.
not.
It's the other one.
End behavior as x decreases.
Mhm.
Yeah, that's the one. No.
No.
No, it's not.
None of them are the same.
So none of these are the same. Now, I want to show you range is just a little bit
I
different.
feel like that's not what the book says.
I don't think that's a book says.
I don't think they would give us a problem like this.
I will, but range for this one, for f of x, range is going to be,
Even if the book says it, he's.
I think it should be range.
It should be infinity to.
okay, range is going to be for f of x, it's going to be 0, comma infinity. What about for this one right here?
Zero, comma infinity.
0, comma negative infinity.
Oh my
No.
gosh, the bracket.
No, I'm stupid. That's x.
The bracket's different.
Yeah, so they're not the same. They're close.
What about signatures?
Well, what does the book say?
Oh, okay.
The book. What?
I'm only asking for Randy.
No, that's fine. It's fair question.
Maybe because it stops.
Mr. D doesn't care if you're
Or is it? Even if the book says.
It's right.
It's gonna say it's right.
He's gonna say the book's wrong.
Watch him to say.
Oh.
I think the book proved him right the way he's walking.
I want you to read this thing right here.
Oh!
Yeah, read it out loud.
Can I hold it?
Yeah, go right here.
No.
She couldn't read it without laughing. It says none are the
I think
same.
she's laughing because she wouldn't let her hold it.
Well, then this is what they want to do. They want to trick us
I told you.
because they.
Yeah, so it's a little bit right. It's a little bit different. It's a thought.
Remember what you said last time, the book's not always right.
Yeah, the book's not always right. Braden is right about that. We've seen the book be wrong before.
Yes.
And the
Yeah.
vicinity, Canadian.
In this case, the book is right, because we've justified all of these, haven't we?
Yep.
We went and justified why they're not the same. So really, it's sort of a thought experiment type question, isn't it?
Approach is infinity.
Yeah, so it's a thought experiment question.
So it's E.
It's none of those.
It's E.
None of the
They're
above.
both increased.
I know it's
It's, you write none of the same, okay?
And X decreases.
But
So
as
none
no, as X increases,
are the same.
they both get bigger. Don't they?
No, that one gets smaller.
Oh.
Yeah.
Yeah, so this one here, end behavior for this one here is as, this is for the red one, I'm going to write this in red. As x approaches infinity, f of x approaches 0. Okay? And for this one up here, I'm going to do this one. As x approaches infinity, f of g of x, because it's g of x, right, approaches infinity. So one approaches infinity, this one here approaches 0. Okay, good. Well, good, you guys had some good discussion about that, and I'm really glad that you tried to argue and made me go to the book. It was really good. And it's going to be helpful. No, really, so it was good class behavior. So it was good class behavior on that one, so I appreciate the class.
Argument is good class behavior.
Yeah, it is. Arguing on topic is really good. That's why 8th period is really good. Those muscle men argue a lot about.
Yes, I did. Get it?
You know what?
Oh, they
My
can-
favorite period is
45.
So go ahead and do this, work on this one too. It's a similar one. I'm gonna get, I'll call on somebody here. Probably just leave it at 18
That's
today.
another trick question, there is no answer.
Go to the book.
I don't want
There is a good one.
Is it?
There is an answer to this
Oh.
one.
I'll get the
The
stuff.
answer is the one that's like, see,
The greater one.
1/4 because it produces it more than the other.
Mm-hmm. 75%.
And I really like that you held me accountable on this too. Like, hey, is it right?
Yeah, we can
I
see.
think it was mainly at.
No phone. What the heck?
Mark, get off your
I
phone.
didn't
Can you try to blame it on me every single day?
Hell, my phone's off.
It's off.
Let's turn it off.
Okay.
Somebody call them.
No, because that would make us be using our phone.
All right.
Just use Siri.
Hey Siri.
Siri.
You have a number.
There's Siri, Cortana, and Alexa.
Tana. That's all that's on the
Cortana.
computers and they can read a Tana, Cortana.
Court. Tana.
Probably for Chrome.
Because,
Chrome's thing and
Not the cheap
hopefully
Siri.
Tana, Mojo.
We're gonna have Jose or Kendall. It's gonna be Jose. Jose, did you figure anything on this?
Oh.
Yes.
All right, Jose, what do we got? What do we have, Jose?
I think we can, so, I put R
So-
at half.
So R of what?
So R equals half.
R equals half.
R equals one, it was 1/2, I'll go like this, right?
Yeah.
Okay,
And then from there, I wrote, so, did I have to make 2 R's?
they have, yeah, they're comparing a different thing, right?
Cause the other R was, 1/4.
It equals 1/4, okay, like 0.25,
Like that.
okay. So reduce to 1/4. Now, hang on a second. Reduce to 1/4, that's a different one, isn't it? That's R equals 0.75, isn't it?
1/4 is 0.25.
No.
Oh, mine is a.
0.75. And that's,
Yeah, reduced to 1/4.
the greater one is 0.75, so that's the answer.
So what you have is you have 1 minus 0.75.
No, it's the other one.
So it's reduced to,
which reduced to 1/4,
Oh, I think it's on what.
right?
5 is taken.
And here you have 1 minus 0.5 equals 0.5, right? So each decay rate, which one is a greater decay rate? This one here, right? And why is that?
Because
It's
it
a bigger
decays at a
number.
greater rate.
Yeah.
Or takes more away.
Takes more away. Very good. I like that articulation.
Very.
So we're going to leave it there today. I appreciate your work. Probably just turning the paper would be a good thing.
Turning it into
But